Hey everyone, welcome to our second video about stoichiometry. In this video, we're going to be talking about how we handle stoichiometry calculations when our units are in grams. In our last video, we saw that the mole ratio can be used to convert between quantities of substances when our units are in moles. But that begs the question, how do we convert from grams of one substance in a chemical reaction to grams of another substance in that chemical reaction? Well, the most important thing to remember is that the mole ratio is used to convert units of moles. That's why it's called the mole ratio. What I mean by that is we have to convert from grams to moles before we can use that mole ratio. We have to do a unit conversion. Now, we've done these conversions in class over the last few weeks. In order to do this conversion from grams to moles, we're just going to divide by the molar mass of that substance. Now, we often have to report our final answer in units of grams, so we'll do another unit conversion at the end of our calculation, converting from moles back to grams. Let's jump into an example to see how this calculation takes shape. For this first example, I'm going to work with the same chemical reaction that we worked with in the first video, and I'm asked how many grams of N2 are needed to produce 30 grams of NH3. So we need our balanced chemical equation. So 1N2 plus 3H2 gives us 2NH3. And notice that in my problem, I'm asked how many grams of N2, so for my final answer, and my initial quantity of NH3 is also given to me in grams. So as we just discussed, my first step here is to convert my quantity of 30 grams of NH3 into moles of NH3, and I'm going to do that by dividing by the molar mass. So I'm going to add up the molar mass of NH3, so 1 nitrogen and 3 hydrogens. I'm using the molar mass of 17.04 grams. And this conversion factor that I've outlined here in yellow is my conversion from grams to moles. So we're going to ask the calculator to help us out there, and we get 1.76 moles of NH3. Now that I have my quantity in moles, the second step in my calculation is going to look a lot like what we saw in our last video. I'm going to use the mole ratio to convert from moles of NH3 to moles of N2. So I'm using the ratio of 1N2 over 2NH3. Again, thinking about getting those NH3s to cancel out. So 1.76 moles of NH3 times 1/2 gives me 0.880 moles of N2. So now I've converted from moles of NH3 to moles of N2. Now I'm not quite done. I'm asked for how many grams of N2, not moles of N2. So I've got one more step. I need to convert this 0.880 moles of N2 into grams. And I'm going to do that by multiplying it by the molar mass of N2. So each nitrogen has a molar mass of about 14.007. So that gives us 28.014 grams per mole of N2. So there's my conversion from moles to grams. And again, we're going to ask the calculator to help us out here. So 0.880 times 28.014 gives us 24.7 grams of N2. As always, I'm rounding my answer to the appropriate number of significant figures, and I'm including units as well. Before we move on to another example, let's just review the steps in that calculation. So first, I need a balanced chemical equation. Now for this particular example we just did, the equation was already balanced, but I always want to make sure that I'm working with a balanced chemical equation before I start doing these calculations. Second, we want to convert the given quantity in units of grams to moles, and we do that conversion by dividing it by the molar mass. Third, we use our mole ratio that we get from the balanced chemical equation to convert from moles of one substance to moles of the other substance. And lastly, since we were asked for grams of N2, we had to convert from moles of N2 that we got out of step 3 back into grams by multiplying it by the molar mass. In our second example here, I'm going to be really intentional about labeling each of those steps so you can see how this calculation comes together. So for this question, we're asked how many grams of MOS2 are needed to react completely with 45 grams of O2, and we're given the unbalanced chemical equation to work with. Now, I'm not going to go through that balancing step by step, but feel free to pause the video if you want to try to balance this equation on your own. But as we go through and we balance it, here's what we get. 2 MOS2 plus 7 O2 gives us 2 MOO3 plus 4 SO2. So now my equation's balanced. Okay, now for the second step, I need to convert this 45 grams of O2 into moles of O2, and I'm going to do that by dividing it by its molar mass. So the molar mass of O2 is 31.98 grams. So you can see I've set up my conversion factor there. And in the calculator, we'll do 45.0 divided by 31.98, and we get 1.407 moles of O2. Now that I'm in units of moles, I can use the mole ratio. So in our third step, we're going to convert from moles of O2 to moles of MOS2. So my mole ratio that I'm using is 2 MOS2 over 7 O2. Again, we think about having the units of O2 cancel out in this calculation, so we put O2 on the bottom. So in our calculator, we're going to do 1.407 times 2 divided by 7, and we get 0.4020 moles of molybdenum sulfide, or MOS2. We're asked for our final answer to be in grams of MOS2. So for my fourth step here, I've got to convert from moles of MOS2 to grams of MOS2. And I'm going to do that by multiplying it by its molar mass. So 160.09 grams per mole of MOS2. And we toss that in the calculator, and we get 64.36. And we do want to be mindful of sig figs here. I'm going to round for 3 sig figs, so we'll go 64.4 grams of MOS2. And that is our final answer. So there we have it. Grams to grams stoichiometry calculations broken down into 4 steps. I hope it's helpful. As always, if you have any questions, please let me know.